Good morning all. On today's session we are going to see the direct memory access. So in direct memory access, how the modern system uses to move the large blocks utilizing the direct memory access without tying up with the processor. So how it's going on, so we are going to see in the today's session. So why we are going to DMA? The limits of the traditional input output, as we saw in the previous classes, like program controlled input output, the processor it pulls a status flag in the device interface. So there will be a continuous overhead from the repeated polling. And the next is the interrupt driven input output. Device sends an interrupt request, and so the overhead is created from saving and restoring the PC and processor state. So the core problem is to transfer a block of words, the processor must increment the address every time, and it should track the word count instruction by instruction. So the limits of the traditional input output devices is this. So how the DMA is going to overcome this problem, we are going to see in the further slides. How the traditional methods is overcome by the DMA controller is it is a special control unit, and it transfers the block of data directly between the input device and the main memory. So without any continuous processor intervention, there will be no continuous processor intervention. So the first is memory addressing. It provides the memory address and all the control signal for all the words transferred. And there is no PC, MAR, MDR, nothing is there for the memory addressing. And there will be auto increment for every memory address, and it tracks all the number of transfers. So it is built into the interface. Okay, so it will be present inside the interface. The DMA controller is a part of the input output device interface circuit. So it is a part. Okay, so the processor intervenes all the input output devices, but here the DMA controller, it is a part of the input output devices interface circuit. Now we are going to see how the DMA works. So the DMA is programmed and it is kept aside, and the processor will be working 24/7. It will be on the on condition. So whenever the DMA it starts, it need to transfer, the processor will fetch the information of the DMA's for instructions, first instructions address, and it will get the access to the DMA. Then the processor stops and the DMA continues to transfer. So whenever the interrupt is raised after the DMA is starting to transfer, so the processor it stops its work. Okay, so the processor it initiates the transfer, but it is free to execute the other instruction while the DMA controller handles the data movement. So on completion, the DMA controller signals the processor via an interrupt. Okay, the processor will initiate its work, initiate the transfer, but it will keep the free to execute other instruction, but the DMA controller handles the data movement. Okay, these are the DMA control registers. So there are three registers: address register, word count register, and status and control register. So address, as we know, it holds a starting memory address for the transfer. And the next is word count register. It tracks the number of words remaining to transfer. And the next is status and control register. It contains read or write bit and done bit and interrupt enable along with the IRQ bit, that is the interrupt request bit. It may also record the error flags, that like zero flow error. How a DMA is in the system architecture. So there will be a processor, a main memory, and a system bus. Okay, so the DMA controller will be there. Along with it, it will contain the disk controller, DMA channel 1 and channel 2 with the high speed network. Okay, so a disk controller it may provide two DMA channels, enabling the two independent DMA operation as if each disk has its own dedicated controller. So registers for address, word count, and status are duplicated for each channel. Each channel there will be the registers, word count, status, as we see in the previous video. So the DMA controller connect the high speed peripherals directly to the system bus. How a bus can be accessed using the cycle stealing or burst mode. So what is cycle stealing? DMA controller steals individual memory cycles from the processor. So DMA devices have higher bus priority than the processor. So among DMA devices, high speed peripherals get the priority. Okay. So the block or burst mode is it gains the exclusive access to the bus for the entire transfer. The processor is blocked from the bus until the block transfer completes. So there are two types of bus arbitration. So what is bus arbitration is both the processor and DMA controller must initiate transfer on the bus, and the device currently allowed to do is used with the bus master. So how the bus master is allocated for transmitting the data is comes under the bus arbitration. So there are two types of arbitration: centralized and distributed arbitration. So centralized arbitration, it has the single bus arbiter. It decides which device becomes the next bus master. So but the distributed arbitration, all the devices can participate in selecting the next bus master, and there is no central authority. Okay, so there will be the current bus master relinquishes the control, and then a bus arbiter, it selects the next bus master. This is centralized. Okay, so new bus master acquires the control and data transfer will be taking on the bus. The timing diagram is the centralized arbitration, how it takes to the signaling protocol. Okay, so always the timing diagram, it will be initiated using the signal protocol. So whenever the bus is ready, it is asserted the BG1, the bus grant line, gets active, and the wait bus busy line, it will wait. And whenever the bus busy line is enabled to 0, it will the bus is free, the DMA, it takes the bus. Okay, so when the first is ready, getting ready, and the bus grant is given for the DMA controller, and it will fetch whether the bus is busy or not. If it is busy, it won't take the DMA to take the bus. If it is free, it will allow the DMA to take the bus. Okay, so the BG1 signal is wired in the DC fashion to all the DMA controller. The bus busy signal indicates bus availability. Okay, so whenever BBSY is equal to 1, the requesting DMA controller may take the control. Okay. So in today's session, we have seen about the DMA. So how DMA is differs from the processor, and how what is the DMA's architecture, and what are the arbitration techniques used in the DMA and signaling protocols. And we are thus we are concluding with the processor initiation and how the DMA executes, and the registers address, word count, and status register is present, and the bus arbitration, difference between the bus arbitration, and how the centralized arbitration technique using the signaling mechanism takes place. Thank you for attending this session. Have a good day.